Okay, welcome back to McNab Chemistry. Today we're going to have a look at the trends in physical properties of group 2 elements. Okay, these are also known as the alkaline earth metals. Okay, so first of all, the group 2 metals we need to consider are magnesium, calcium, strontium and barium. Okay, and then the physical properties we need to consider are atomic radius, first ionization energy and melting points. Okay, so if we have a little look at our table here, we can see there that magnesium, calcium, strontium and barium, the atomic radius increases as we go down the group. The first ionization energy decreases as we go down the group, and then the melting points as you go down the group generally decrease, but we have one anomaly in magnesium. Okay, so let's first of all consider the trend in atomic radius. Okay, so as the atomic radius increases as we go down group, this is because as we go into the next period, the number of electron shells increases. So that's really very simple, isn't it? So as we go down the period, let's have a little look at our periodic table here. Okay, there we go. Okay, beryllium, magnesium, calcium, strontium. This is period 1 here. Period 2, that means I've got 2 electron shells. Period 3 means I've got 3 electron shells. Period 4, 4 electron shells. Period 5, 5 electron shells. Okay, so my atomic radius as I go down the group increases because I have an increased number of electron shells. Okay, and we can show that with a nice little graph that looks like that. So there you go. Magnesium, calcium, strontium and barium, the atomic radius increases as we go down the group. Okay, the next physical property we've got to consider is their first ionization energies, so the element's first ionization energies. Now if you remember back to part 1, first ionization energy was the energy required to remove 1 mole of electrons from 1 mole of atoms in their gaseous state. Okay, so basically we're looking to see which of these elements can lose that 1 electron from its outer shell most easily. Okay, so first thing to note then is that the first ionization energy decreases as we go down the group. This is because the outermost electrons become more shielded from the positive nucleus as the number of electron shells increases. Therefore, less energy is required to remove 1 electron from the outer shell. Okay, so therefore the first ionization energy decreases down the group. Okay, and then finally let's have a look at how the melting points of these group 2 elements change. Okay, so first thing to note here is that all group 2 elements actually have really quite high melting points. Okay, so all group 2 elements have high melting points. They're metals, if you think about it. That means they have metallic bonding. Okay, and this is because there is an attraction between the positive nuclei in the layers and the delocalized electrons in the outer shells. Okay, so we've got these attractions between the positive nuclei, or as it's often written in the books, the ions, the layers of ions surrounded by a sea of delocalized electrons. Okay, therefore we quite a lot of energy just to break that bond between that positive nucleus and the delocalized electron. Okay, but there is a general trend. So generally the melting point of group 2 elements decreases down the group, and this is because the charge to size ratio of the ions decreases. Okay, so they both have 2 electrons in their outer shell because they're group 2. Okay, but their size gets bigger. Okay, so they've got 2 electrons in their outer shell, but their size gets bigger, so their charge to size ratio decreases down the group. Therefore they attract the delocalized electrons in the outer shell less strongly. However, let's have a look at the one anomaly. Okay, so my general trend looks like this. Okay, generally the melting points decrease as you go down the group. Okay, but magnesium actually has a lower melting point than calcium, strontium and barium, which is unusual and doesn't quite fit the trend. Okay, so let's go through this steadily. Magnesium has a lower melting point than calcium, strontium and barium, and this is because the metallic crystal in the magnesium has a different structure. So we say this, so i.e. the crystal structure is different in magnesium to the other metals in group 2. Now you don't actually need to know these different structures, but it doesn't hurt to have a bit of an understanding. Okay, so magnesium has a crystal structure which is called a hexagonal close packed structure. Calcium and strontium both have face-centered cubic structures. Okay, and barium has a body-centered cubic structure. Again, you don't need to know this, but just to understand it, let's have a little look at this picture here, this nice little diagram. Look at that. Okay, so in magnesium, if these are our layers of ions, or effectively our layers of positive nuclei, okay, layer A is different from layer B, and layer B is different from layer A above it. So our orders of layers is A, B, A. Obviously A's are the same. Okay. In calcium and strontium, the face-centered cubic structure has 3 different layers packed on top of each other, which are different. Now just think about if you were building a wall, a brick wall, okay, this would be one brick in one place. These bricks would be in a slightly different place and maybe overlapping these bricks, but then this layer would be the same as that layer. So that clearly wouldn't be as strong as having 1, 2, 3 layers all completely different, all overlapping each other in a different way. Okay, and that's how metallic bonds form. And they form in layers, and you can have different arrangement of the layers, which gives these metals different melting points. Okay, but back to our summary for what we need for A-level chemistry. Okay, you can see that's a summary of our melting points. Okay, so magnesium is lower than calcium, strontium and barium, but generally the melting points decrease down the group, apart from the magnesium, which is an anomaly because it has a different crystal structure. Okay, thank you for watching. Don't forget to like and subscribe and click on the bell notification to keep you updated.